For years, the goal of generative AI has been the perfect static image, the flawless fantasy portrait. But what if it was just the starting point? The next frontier isn't just creating a character, it's bringing it to life. This is FantasyPortrait, and it's not a checkpoint or a LoRa. It's a dedicated animation framework developed by the researchers at Alibaba's ACV lab. Its purpose is to solve one of the most difficult problems in AI video, transferring the facial performance from a real person in a driving video onto a generated character without artifacts or identity loss. It leverages a diffusion transformer architecture with a specialized masked cross-attention mechanism. For us in ComfyUI, that translates to a higher degree of control and, more importantly, a higher fidelity output, especially in challenging cross-reenactment scenarios where the source and the driving faces are completely different. In this deep dive, we are going to put those claims to the test. We'll walk through the entire workflow node by node. We'll analyze its ability to capture subtle expressions, and critically, we'll benchmark its performance on a range of different character styles. Let's begin. Support the channel and press subscribe. First, let's deal with the model download. Head over to Qwen's Hugging Face repository. Under Files and Versions, you will find the FantasyPortrait folder, and here you will find the FantasyPortrait FP16 Safe Tensors file. Download that and place that in your Diffusion Models folder. The link is in the description. So this file download is in addition to the other models. For this to work, you need to have the Wan 2.1 image to video. That's the 14 billion parameter. I'm using the FP16. You need to make sure you have the clip encoder, the UMT5 XXL. If you don't have it, download it and make sure you place it in your clip folder. And you need the Wan VAE 2.1. Make sure you place that in your VAE folder. Now your models are in the right places. Let's spin up this workflow. So you can grab this workflow from the GitHub repository, but I've placed a modified copy on codebreakers.site. You're welcome to try that, and the link to both of those are in the description. So grab the workflow JSON file and drop it onto the ComfyUI canvas. That will load up the workflow. So the first thing to notice is that this workflow looks a bit like a spaghetti junction, but don't be intimidated by this. We'll run through it logically step by step. If you have any missing custom nodes, you should now get the option to load them. Go into the ComfyUI manager and install missing custom nodes. Restart ComfyUI and refresh your browser. Any missing custom nodes with red borders should now appear. If you still have any red borders, then it means you must update ComfyUI and update all custom nodes. So go back into the manager and you will see the button for update all. You can also git pull the Wan Video Wrapper update from its custom nodes directory. So now we're all updated. Let's take a look at the workflow. First, let's make sure our models are loaded. On the left hand side of the workflow, you will see the FantasyPortrait loader. Make sure your FantasyPortrait model is selected inside this loader. In your Wan Video model loader, make sure your Wan 2.1 model is selected. Now here I've realized I didn't mention the LTX LoRa. Now you may already have this, but if you don't, it's also available on Qwen's repository on Hugging Face. Make sure you download that and place it in your LoRa folder. I'm using the rank 64. But feel free to try the others. So make sure this LTX LoRa is selected in your LoRa loader. Make sure your Wan 2.1 is selected in your VAE. Make sure your UMT5 XXL is selected in your clip loader. Now let's quickly run through the settings. So on the left hand side we have our width, height and frames. So you can select the sizes in here. I'm going to set it at an aspect ratio of 16:9 and set it to 121 frames. Let's load in a control video. So this control video will be clipped to 121 frames. I will show you later how we can generate longer videos, but let's load in an image and have a run at this workflow. So when you run this, the workflow sets up the necessary parameters for the video generation. This includes defining the width, height, and the number of frames for the output video. These values are then stored for later use. Simultaneously, it loads the two essential media inputs, the driving video, which provides the motion, and the source image, which is the portrait to be animated. Both are immediately resized to the correct dimensions. The frames from the driving video are sent to the FantasyPortrait face detector. This node analyzes each frame to extract facial landmarks and create portrait embeddings that capture the motion and expression. At the same time, the resized source image is sent to the ClipVision encoder. This creates the image embedding that captures the static identity, the look of your character. A text prompt is also encoded to provide additional guidance for the video generation. This combined data is fed into the main Wan video sampler. This is where the new video is generated in the latent space. Finally, the latent video is sent to the Wan Video decoder. It uses the VAE to convert the latent data back into a sequence of viewable images. Now, I have not touched the settings in the Wan Video sampler. The steps were set at 6, the CFG is at 1, and the shift is at 5. It's a fixed seed, and the scheduler is DPM++ SDE. Now, I don't advise you mess with any of these settings, as this is just working fine. But feel free to experiment. Now, this is what it generated. It took just over 174 seconds, which is just under 3 minutes. So it was 121 frames. So Qwen has placed these image concatenate nodes multi in here, which gives this multi-image. And also the problem is you can't do long generation videos. So it's great for testing, but I will adapt this workflow so we can make it a workable version. But props to Qwen for bringing us this far. Here's what the generation sounds like with the audio.
And in 5 years, we have gone from this thing that could barely write a sentence to a thing that is PhD level intelligence in most areas.
And I'm not sure what you think, but it is what it is. I'll let you guys judge if it's good enough for you. But let me adapt this workflow and then we'll give it another try with a longer generation. So how are we able to generate these longer, more complex animations without instantly running out of VRAM? The answer is memory management, and it's controlled by this critical node, the Wan Video Context Options. Think of this as the model's short-term memory. A video model can't look at all 200 frames of the sequence at once. Instead, it processes the video in smaller, manageable chunks, and this node dictates exactly how that happens. Let's break down the key parameters. First, the context length. This is the size of the chunk. Are we asking the model to look at 60 frames, 30 frames, or 100 frames at a time? A large number can improve consistency, but it comes at the cost of higher VRAM usage. Next, context stride. This controls how the model moves its attention across the timeline. For the smoothest result, we can set this to 1, forcing the model to meticulously analyze every possible overlapping chunk. And finally, context overlap. This is the secret to seamless transitions. It tells the model how many frames from the end of the last chunk to remember when starting the next one. A healthy overlap ensures motion and details flow coherently without visible cuts or jumps. So by balancing these settings, we can push beyond the normal memory limits and generate much longer, temporally stable sequences. It's the key to scaling up your generations. So we can connect the output of this node to the context options input on the Wan Video sampler. I will set my context frames to 81 and context stride to 4, with the context overlap to 16. This I found worked well for me, but experiment with your own setup. So now I will run the workflow and try to generate the full 296 frames of the clip. Now with the context options, this should work because each chunk should not be more than 81. So this took just under 6 minutes to generate. Actually took 348 seconds, but I was able to generate the full length. And here it is.
And in 5 years, we have gone from this thing that could barely write a sentence to a thing that is PhD level intelligence in most areas.
All right. Now before we look at some final renders that I did, I just want to pause for a moment. My single goal with Codebreakers is to go deeper than a surface level tutorial. We deconstruct these complex workflows, analyze the data, and find specific techniques that deliver professional, repeatable results. It's a process that involves hours of testing, troubleshooting, and benchmarking. If this deep dive has provided you with some real value today, if it helped you understand this model better, or saved you time in your own projects, then the single best zero-cost way to support this channel is to subscribe. It's the clearest signal you can send that this is the kind of in-depth content you want more of, and it will genuinely allow me to continue making these videos for you. So thank you for that. Now, as promised, here are a few final generations where I really push the model to see what it's capable of.
I mean, here was this moment, something that I had dreamed of, my life's passion. It was cinematic storytelling. And the door was opening, and I didn't want it to close. I mean, this is something that I was absolutely certain that I wanted to do for the rest of my life.
You guys got to subscribe to Codebreakers.
Cannot be destroyed, Gimli, son of Qwen, by any craft that we here possess. The ring was made in the fires of Mount Doom. It must be taken deep into Mordor and cast back into the fiery chasm from whence it came.
And in 5 years, we have gone from this thing that could barely write a sentence to a thing that is PhD level intelligence in most areas.
And as you can see, when you combine a high quality source image with a clean driving video, the right context settings, the results are absolutely phenomenal. The consistency and expressive detail are a significant step forward. And we're not done yet. For years, AI image editing has been a clumsy process. You paint a mask, you write a prompt, and you hope the model gets it right. And the results are often unpredictable. But what if you could simply talk to your image? In the next Codebreakers deep dive, we're going to deconstruct Qwen, the new vision language model from Alibaba that turns image editing into a conversation. We're not just talking about removing an object, we're talking about drawing a box around a person and typing, add a leather jacket, or telling the AI, change the season in the background to autumn. It's a fundamental shift from prompting to directing. We'll benchmark its performance and show you the entire workflow. Get ready to edit your images with words. Subscribe now so you don't miss it.
Another workflow, another set of secrets unlocked. Stay curious.